Thank you, Ron, and hi, everybody. We're very happy to be here. Ron, if you could enable the share screen, please, so we can also share the presentation. Great. All right, so we're going to start to hit off with a quick presentation to tell you a bit more about UVeye and about the company and who we are very quickly before we dig deeper into the technology. I'm Yaron, this is Amir, the CEO. And at any moment, you'll see at the bottom of the footer of this presentation, the email which you can get in touch with us. We're going to mainly speak today about a new patented technology, which is how we fingerprint vehicles using computer vision and deep learning. So let's speak about the agenda. Basically, we're going to hit off with a quick history and overview about UVeye, just that you understand what we do, what are the challenges that we are trying to solve. We're then going to speak about the challenge of fraud attempts using stolen or fake license plates. We're going to speak about the sensitivity of license plate and the lack of security in that using license plates in vehicles. We're going to talk about the solution and technology. I'm going to hand it over to Amir to speak about what we managed to do, some examples, how we look at a vehicle's undercarriage and different parameters, and actually give it its own unique fingerprint using artificial intelligence. Then we're going to head off to a live demonstration here in our headquarters, in our showroom. We're going to show you a vehicle driving over our systems, and you're actually going to see the system and user interface in action. And important to say that during all of this presentation, you're really welcome to click and write some questions in the comments, and Ron is going to facilitate the Q&A in the end, and obviously we'll do our best to answer. So without further ado, I want to show you a quick video that shows a little bit about what UVeye does and its appliances in the Homeland security. We'll talk a bit more about what we also do in the automotive world. The focus today is around Homeland security. So with your permission, I'm going to share a quick video that shows and demonstrates what we do. Okay. Okay. So if you can see my screen.
UVeye sets the global standard for under-vehicle inspections. The vehicle's undercarriage presents a difficult point for security inspections, offering adversaries an ideal place to hide illicit materials such as weapons, explosives, drugs, and more. Legacy inspection methods such as mirrors and dogs lack the accuracy and speed for the scale and precision required to meet today's operational needs. Helios from UVeye levels the playing field, simplifying under-vehicle inspections, scanning, detecting, and alerting on issues in a matter of seconds. Multiple high-resolution cameras capture sharp, high-quality images from all angles, which are quickly analyzed by UVeye's deep learning algorithms to identify anomalies in the vehicle's undercarriage which could indicate a threat. Helios is already deployed at over 100 sensitive sites across the globe, including seaports and airports, military bases, embassies, power plants, and more. We invite you to connect with us to learn more about how UVeye and Helios can change the way you think about vehicle inspections, improving speed, and providing valuable data that can help save lives and achieve your security objectives.
All right, great stuff. So, as you've seen in the video, the product that we offer in the Homeland security market, both in stationary and in mobile, has a flow of a product, a hardware that is in the ground or on the ground. A vehicle simply drives above it, and within seconds, we operate a software algorithm, a deep learning algorithm, like in the seaport entrance access lane, as you can see, can be multi-lane, can be single lane, and we can detect anomalies and anything that shouldn't be under the vehicle within seconds. As part of that, we patented an technology of fingerprinting every vehicle that goes over our system, and that's what we're showing today. So just a word about the technology. When we see a vehicle, whether it's in the automotive or in the Homeland security market, we segmentate and we divide it into parts. So we look at an undercarriage of a vehicle, and we look at the muffler, we look at the chassis, we look at the exhaust pipe, and then we can tell you if anything is wrong with the texture, with the color, if anything is broken. So this is using deep learning. We've already scanned millions of vehicles since 2016. And once we see that undercarriage or tires or the body of a vehicle in the automotive market, when we do those kind of things and apply this technology, we know how to segmentate and divide and then look for these anomalies and see every problem. So just about the Homeland Security market, which we're speaking about today, there's been a legacy of different solutions, right? So starting from a guard with a mirror, as shown in the video, and other technological solutions, we like to say that we have a new family, a new generation of intelligent vehicle screening solutions. So a scanner, which is put at the entrance or at the exit of a facility and has a feature called first pass or first inspect, meaning we can see a threat without a reference image, without ever seeing a vehicle before. We can identify a threat. Could be an IED, could be a weapon, could be smuggling, could be a modification sometimes. We do a 3D model of the undercarriage of every vehicle, also in the automotive world for other purposes. We know how to compare vehicles, recurring vehicles, and show that in an intuitive user interface. And what we all came together to discuss today, we give a unique vehicle ID for every vehicle that our system sees. So some of the use cases in the Homeland Security that we are working with, you can see in front of you: energy facilities, seaports, airports, embassies, military, government facilities. We're installed in over 100 places all around the world. Worth mentioning that we're also working in the automotive industry with this product and a couple of others in places like fleets, like repair shops, like dealerships, like OEMs. So we're pretty developed in that market as well, using that same kind of deep learning, artificial intelligence technology when we look at a vehicle and we know to tell you everything you need to know about it, whether it's security threats, whether it's mechanical issues, whether it's cosmetic or other issues. So a couple of words about the company before we dig into the technology. We have 4 offices today in the US, in Israel, in Germany, and Japan, with over 100 employees. We're deployed, as I mentioned, in over 100 sites. The company has 8 patents, or more actually today, with the one we're exposing. And we've hit quite a lot of funding, including strategic investors like Volvo and Toyota. This is just an example of how one of our systems, which is called Atlas, for the automotive world, looks like. This one is being installed in Volvo in Sweden. So keep in mind that all this technology of looking at the vehicle, looking for anomalies, also fingerprinting it, can be used in many applications, and we do that as well. So just to summarize some of our features, which I mentioned, when we look at a vehicle and we say intelligent vehicle screening, we have a few features that differentiate us in this market. And the highlighted one is what we're going to speak about today. When we see a vehicle, we know not to rely just on the license plate and give it a unique identifier using artificial intelligence. So what's the challenge really? This video, by the way, is a video that was shown here in the news in Israel, of a couple of crooks that actually stole a license plate to enter a secure perimeter, a building. And what happened is that they actually shot someone. So they knew that they could enter a certain facility with a license plate. Maybe they stole a list of recurring vehicles, and they managed to fraud that license plate and get in. And what's important to understand is that license plates are as sensitive as the social security number as a credit card or any other kind of identification, yet they're so easy to get off or hold off. They're so easy to replicate and duplicate. And that's what we are here to solve today. We're here to give and to show you a technology that's been patented, that knows how to take hundreds and thousands of images of a vehicle and use a few parameters to give it a unique identifier that we developed here at UVeye. So these are just a couple of articles further emphasizing this issue. And obviously it's a worldwide problem that a lot of our customers actually came to us and presented. And that's why we created this kind of feature. So without further ado, I'm going to hand it over to Amir, our CEO. And after this part of the presentation, we'll show you the demonstration. Now we're going to show you exactly how we develop this technology and what it means.
Thanks, Yaron. So basically, as Yaron said, we understood that license plates are not enough because they're easily can be faked and duplicated and copied. So we created something called vehicle identity markers. I know it's kind of like the VIN that everyone knows. So we created a VIN which gives us a more broad parameters and markers that will be able to identify the vehicle. So yes, we use different components of the vehicle in order to be able to really give a unique identity for every vehicle that we inspect. We use a lot of parameters from the undercarriage that we inspect. Of course, we do take into consideration as one of the parameters we use the license plate, but also a lot of parameters from the overview of the image, such as the make, the model, the year of making, the body type, the color of the vehicle, but still it's not enough. It doesn't solve the twin problems, because if we see the same vehicle, same model, same color, we still would like to differentiate between the different vehicles. So what we basically do is we collect a lot of different markers and parameters from the undercarriage that helps us to uniquely identify every vehicle we inspect. So I want to start and show you some examples of what we mean when we talk about markers, and how unique and how hard it is to really understand whether we are seeing the same vehicle. So this is how a typical undercarriage look like. These are different scans of the same vehicle. It's easy to see that this vehicle is the same vehicle in both of the image, just different scans. We see the different components. We see here the orange part similar in both of the image. All the information about the engine at the front of the vehicle is the same for both of the image. And as well, the other parts that we're seeing, the exhaust pipe, the muffler, the fuel tank in same location. So basically, we're seeing the same vehicle, just in different scans. Here we see the same manufacturer, but different models. So we see we do have some changes between the images. Here the engine is completely exposed, unlike in this image. The muffler and the exhaust pipe looks completely different. And of course, the area of the fuel tank is different between the two vehicles. But what do you think about these two images? Is this the same vehicle? Is it different vehicle? So I'll give you a few seconds to try and guess, and then we'll explain exactly what we see.
If anyone has ideas of how they would identify this, you're welcome to write it in the comments as well. And later on, we can discuss and use your talents also in the Q&A.
Absolutely. So although it looks like it's the same vehicle, actually those are two different vehicles. It's the same manufacturer, same model, but different submodel. Different submodel can mean different year of making, or it can be different regions in the world that simply use different components. So we see the front area looks relatively the same in both of the images, but we see that the other components are completely different. And it's hard to see from first look. But those are kind of the things that we use in order to generate and understand the vehicle parts. But what about this vehicle? Is it the same vehicle or is it a different vehicle? So we see a lot of areas are the same in both of the image. Both of the images have contained that orange part, the muffler and the exhaust pipe looks the same. It's the same location for the fuel tank. So in the first side, it looks like it's the same vehicle. But when we further inspect what we see that actually this is the same manufacturer, same model, and same submodel, but those are two different vehicles. And when we look further into the images, we see that here we can see different handwriting on the fuel tank. And here at the front, where the engine and the shaft, we see different wear and tear of the vehicle. So same component, different wear and tear can give us the ability to understand that this vehicle is unique. So we've shared some examples of how important it is to be able to really understand the vehicle parts and to be able to segmentize all the different components in the vehicle. So basically, when we think about it, the undercarriage verification is very similar to what we see from face detection and face recognition systems. Basically, we need to create some kind of verification system or a decision system that understands the undercarriage and the models, and then produce us the fingerprint for every vehicle that we inspect, but also gives us the ability to compare between the different fingerprints in order to get similarity score between the different vehicles that we are seeing. So in the first step, we had to create a segmentation, a very accurate segmentation of the undercarriage, of the different parts that we have. In most vehicles, we're seeing the same parts, they just look different. So engine, bumper, chassis, heat shield, fuel tank, suspension system, wheels, we need to understand all of those components and all of those parts to be able to understand what we are seeing. And then after we understood and we created a very accurate segmentation, we created a language that lets us understand what parts we are seeing and exactly how it looks like. So we created descriptors that describe how really the component we're seeing looks like. So if we take two different parts from two different vehicles, although they have similar areas that looks the same, we're able to have descriptors that really tells us that and describe how all of the whole component and the whole part looks like. Because although these parts are similar, here we see areas that are not similar. And we need to be able to really understand those and to describe those in our language so the fingerprint will be accurate. And it goes and relevant for all the parts that we see in the undercarriage. But we didn't want to stop there. We want to have more markers, more parameters that we take into consideration, especially because we understand that some of them can be changed, but we still want to be able to differentiate and understand the fingerprint of the same vehicle. So we also added a lot of different markers that includes the bolts and the screws that we have in the vehicle. So not only we use the type of the screw, but also the angle. And what we also use the wear and tear of the vehicle. So big scratches on that are not easily to repaired, different types of damages, broken parts, but also damages to the undercarriage. We take all of them into consideration when we generate a unique fingerprint of the vehicle. Some of you may ask, so what will happen if I go to a garage and repair some of the things here? Well, that's perfectly okay because we take a lot of different parameters. We use a lot of different, we use our language to describe the parts and the components using our language. So it's perfectly fine. If you fix some of them, we'll be able to adjust and understand it's still the same vehicle because we have a lot of parameters that we use. And this is how it looks like. So we compare and understand the fingerprint once we see the vehicle again. And then we have our similarity algorithm that calculates how close is the fingerprint that we just generated for the vehicle comparing to the past scans. And of course, the higher it means more probability it's the same vehicle. When it's lower, it means someone changed something. Someone took the license plate, put it on a different vehicle, and then tried to enter the facility. It gives us the ability to understand over time and to adjust over time our fingerprints. The more times we see the vehicle, more parameters we can collect, more understanding we have about the specific vehicle, but also it helps us to do the comparison, a very accurate comparison to understand exactly what was changed, added, or modified in the vehicle. And of course, eventually we show the operator exactly what he needs to see to understand if someone added something to the vehicle. It's ideal for secured places that have repeat traffic, such as government facilities, ports, banks, prisons, or any other location that you have a returning customer or employees.
Can I just add to that, Amir, with your permission? So the user interface you folks have seen is the user interface for the Homeland security system. the automotive world. So basically, when you see a compatibility score like that and modifications of recurring vehicles, when we were installed in a very big MOT or DOT facility in Asia, and they wanted to see modifications in a vehicle for getting the MOT license, we were able to identify the same vehicle and compare and see any kind of modifications that maybe were illegal to do in that certain country. So as I said from the beginning, the technology is there, and the applications are many, whether it's Homeland Security or automotive or probably other use cases as well.
Exactly. So I think it's a good time for show a live presentation.
So what we'll do now is, with your permission, I'll just say a couple of words about how you can contact us. Amir is gonna jump to the room next door, and he's gonna open the dashboard of the user interface, and he's actually going to get ready to show you the demonstration today. I just want to give you our contact details. Meanwhile, if anyone wants to be in touch personally, these are our emails. You can also get in touch with us at info@uveye.com or visit our website. We have a downloads area. We have many use case videos, both for the Homeland Security and for the automotive world. And what we're about to see is we actually took a vehicle, a Renault vehicle, that is going to drive over our undercarriage system. I'm warning you in advance, this is our laboratory, this is our showroom, so there's a few covered things here because they are systems that are going to be exposed and have a debut soon in the automotive world, actually. But you'll see here a few systems. The one that's relevant is the one on the ground, the scanner on the ground. We call it Helios. You're going to see a vehicle driving over it, and then you're going to see the flow of how we see it for the first time. We are going to plant a couple of threads in it or in the undercarriage. You're going to see how we find it automatically. You're going to see how we compare that same undercarriage to some modifications and changes. And then we're actually going to do something really cool, because we got another vehicle which is identical, and we're going to put the same license plate on another vehicle, and we're going to see that compatibility score. Let's see if we can switch to the other computer and continue in a moment from there.
Hey guys, just to confirm, it looks good. I'm seeing Amir on my screen now. Amir, I think you're muted though.
Amir?
Yeah, can you see my screen?
As I could hear you from this screen, and you can share your screen as well. Amir, you could share screen on yours, maybe? Reconnected. Sorry, folks, we're just some technical issues. We're connecting with the showroom camera here. So with your permission, just a minute or so. Ron, can you give Amir's computer, please, host sharing capabilities?
Yaron, since you're the host now, I think you might have to do that. If you can hover over his name, click on more, and make him the host.
Okay, so I'm making him a co-host. That's okay.
Yep.
Here, let's try that again. Okay.
Okay, so I hope everyone can hear me. Basically, what we'll do, we'll show you exactly how the system works, and we'll present right now how the first pass, meaning right from the beginning, we'll be able to find all the anomalies that are being added to the undercarriage of the vehicle. So what we will do now, Gabi will add some anomalies to the undercarriage of the vehicle. And you can see from all the different anomalies we have in the case. Hope you can see. Hope you're able to see all the different anomalies we have in the case, and we'll choose to.
Yeah, Amir, just to let you know, we see a screen that says waiting for
Choose
vehicle pass.
to add.
Wait, guys, could you see the screen from your Ron's computer? You should be able to see. Ron, can you see it?
Right now, we see waiting for vehicle pass.
Yeah. No. Okay. It's okay now?
Yeah, it's good.
Okay.
So you'll be able to see the case with all the different anomalies we have. Those are represent security threats. And we'll take two of them and we'll put them in the undercarriage of the vehicle so we can simulate how the system could really find anomalies, detect anomalies right from the first scan, even if we haven't seen the vehicle before. So bear with us, and you can see the guys are adding the anomalies to the undercarriage, and then the vehicle simply drive above the system, doesn't need to stop, and within seconds we'll able to detect all the anomalies, but also as we spoke, we'll be able to fingerprint and generate a unique ID for the vehicle.
בוא נעצור רגע את המסך שלך, שיוכלו לראות את הנסיעה, ואז תחזיר. אוקיי.
Okay, so you can see the vehicle has passed through the system. Within a few seconds, we're able to see the undercarriage image, and the vehicle was able to recognize everything that we've added to the undercarriage. Of course, in order to see the resolution that we're able to get in the system, I can zoom in and you can see what high resolution we're able to achieve in a very few seconds, and from the cameras that just inspected the undercarriage of the vehicle. Of course, I can zoom into every anomaly the system was able to detect and understand exactly what we're seeing. But also, it's a bit hard to understand what anomaly we're seeing here at the back. So I can change the view angle of the system, and now it's much more clear to see that we have a gun in the undercarriage that the system was able to automatically identify. Switching back to the main view, we'll ask the guys to remove the anomalies from the undercarriage so we can have a clean scan of the undercarriage, and they'll simply drive through the system again. So we already see the new scan of the vehicle, and within a few seconds we can see that the vehicle is completely clean. But as we discussed, we can already see that the vehicle ID is confirmed, meaning the system recognized that it's the same vehicle that went through the system again, and no one changed anything. Here we can zoom in and see, of course, again, the high resolution that we are able to see. And now we would like to simulate how the comparison works in the system. So the guys are adding anomalies, different anomalies in the undercarriage of the vehicle. So we will be able to see how the comparison now as a returning vehicle, how it looks like.
Just to check, I know someone in the chat said there's problems. You're all supposed to see Amir's computer, which is sharing the user interface, and also a camera of the vehicle and everything that's going on when we are planting the different anomalies, when we're going to change the license plate and so on. So I hope it's okay. And if not, maybe Ron, you could help us and chat to the participants on the chat in the Q&A.
Yeah, no, it's actually been looking great.
Okay. So the vehicle drives above the system again. We're able to see a new scan, and the system inspect for the anomalies. And now we already can see all the anomalies that the system was able to detect. And now what we've done is to do comparison. Because the system was able to see a clean vehicle, we're able to understand what was added to the vehicle. So we can see someone try to do smuggle some drugs, probably, as it seems like. But here we can see something that we don't really understand what we see. So changing to the different angle can expose exactly what someone tried to hide here, but also we can go into the comparison mode, so it will be easier to understand and see the changes. And of course, we need to realize that we produce 3D models in the backend, so we're able to really put the images and the models one on top of the another, so it will be easier to understand exactly what changed. But also we can show a side-by-side the images, so we can really see what someone tried to add to the vehicle. And now what we're going to do is we're going to take the same license plate, same vehicle, same model, same submodel, but we're going to take the license plate and put it on a different vehicle, which is the exact same vehicle as we used for the previous scans. Okay, so you can see that the guys are changing the license plate from the vehicle that we use for scanning right now for all of the inspections, and put it on a completely similar, identical vehicle as used for the previous scans. Okay. Now exactly the same. The new vehicle will drive above the system. We already see that new scan was added. And this is how the undercarriage looks like. And now we see this, that the system detected a possible fraud attempt. So although it's the same license plate as we've had with the previous scans, the system detected that something is not okay, meaning someone replaced the license plate and the fingerprints are different. So if we compare between the two scans, we can see that the undercarriage really looks different. Although it's the same vehicle, same model, it really looks different. And this is exactly what our system is used for. We're able to understand, even when it looks completely the same, we're able to understand that the vehicle is not the same, although it's the same model and same submodel. We're still able to differentiate between the two use cases. Yaron, back to you.
Yes, sure. So that was the demonstration. I know we had a little bit of technical difficulties, so we do apologize for that. But we do hope that you have got the gist and seen our system live. So if you guys want to go ahead, Ron, maybe you want to facilitate and help us ask some questions. We'll be happy to answer, and we'll be happy to give our best shots.
Yeah, definitely. Actually, that presentation went really well. It was fascinating to watch, and I think the technical problems were minimal with all the moving around and all the moving parts. So yeah, we do have several questions. A lot of people are really interested in this technology. Let's see. First question, are you comparing it regarding this whole process we just watched? Are you comparing one-to-one picture, or are you comparing the new picture from your whole database?
To be able to find anomalies. So basically we have two ways of what we do. The first one is in order to find anomalies, even right from the first scan, we're not comparing to one-to-one. We've created an AI algorithm that really understand how the vehicle is supposed to look like by understanding how the parts of the vehicle is supposed to look like. And then we try to reconstruct based on what we already know how the component's supposed to look like. And then we compare the reconstruction of the algorithm to the images that we just captured, to the 3D model that we'll build that we just captured. And then if there's a big gap between them, we mark that gap. And this is how we recognize all the anomalies right from the first scan. But in order, when we do the comparison, after we saw the vehicle a few times, we also build a model for that specific vehicle. And then we do a comparison to all of the inspections for that specific vehicle based on the model we built for it. And it's something that happens on the fly, meaning the system does it automatically.
All right, great. Can fraudsters hide drugs or bombs so that they are undetected once they know that UVeye is used where they're about to enter? Can they avoid the system, in other words?
So no, and this is why I guess it really depends. So if someone try to smuggle and put something around the undercarriage area, but also we have more parameters that we take into consideration. This is exactly why you need multiple angles that will give you the ability to really find things that were added, even if they try to conceal them. So this is why it's very important. We didn't mention, but we do have 5 cameras in our system that are taking images in different angles. So it's very hard to conceal something that we will not be able to see. So if someone tries to add something in the area of the undercarriage and soon in other places in the vehicle, we'll be able to detect those as well.
Okay. Is it possible to integrate the system into city surveillance and speed detection systems?
So absolutely, yes. We do have a full API that can either push all the information and all the data that we capture, but also can be used in order to query all the information from our system.
All right. What type of cameras and how many cameras do you use for this project?
So we have 5 cameras that are taking images from different angles. All the cameras are industrial cameras taking high resolution images. Important to say, we take hundreds of images from every camera every second, and eventually we build, using stereo vision, we build a 3D model out of the undercarriage.
Can I just add to that, Amir? So if you go to our website at uveye.com, you'll see that we actually have 3 products. The undercarriage scanner, which you've seen live today, we call it Helios, has really 5 cameras. There's a mobile version which has a bit less cameras, but also does the same kind of angle work. We also have two other products. One of them is called, another one is called Artemis, which scans the tires of vehicles for fleets, for dealerships, for auction sites, and so on. And it's being distributed now all around the world. And the third one is called Atlas, which is a big arc that you might have seen it here also in the showroom, that can look for scratches and dents down to 0.5 millimeter of all the body of the vehicle. For reconditioning, again, commercial fleets, second-hand cars, rentals, and so on. These devices have different amount of cameras, but the technology behind it, the deep learning behind it is the same. Even the vehicle ID that we're speaking about now can also be applied there. So there's 3 products. You've seen one today that has 5 cameras. The 2 other has different amount of cameras. If you wish, you could just go to uveye.com and you can see at a header a link that shows you the 3 products.
All right, thanks. How widely is the identification of the vehicle shared among scanning entities, i.e., are scans at one secure location being included in comparisons at another location where security is maintained by a different company?
So if it's a different company, we don't share any information between customers. If it's one customer that have multiple entrances or exits and eventually would like to send all the information into one server, it's something we support, but we don't share information between customers.
All right. Is this a system where a vehicle owner could preemptively register their vehicle's identification in case of future theft?
So that's a great question. Yes, he can, but it's more used for Homeland Security purposes than to find a vehicle, whether it was stolen.
Okay. I'm not sure exactly what they mean by this, but is there a percentage in the system for verification? I guess maybe a percentage match, a threshold.
Yeah, so as you saw the user interface, we have a compatibility score, which is, we indicate it in like a traffic light of green or red, but it gives the percentage of compatibility that we saw between the 2 undercarriages or the comparison. So we saw it's the same license plate. We look at the database after we gave it an initial vehicle ID, and then we compare the 2 to show the match. Obviously, if it's the same one, it should be over 90%. It should be very high. If it's lower, that's how we actually score it with a percentage.
Okay. Where is your US office, and do you have any areas where we can view these concepts?
So absolutely, yes. We have 2 offices. We have an office in Ohio, in Cleveland, and we have an office in Connecticut. We are installed already in the World Trade Center, and we have some demo sites that we can host and show all the features and abilities and our technology of the product.
Can I just add, Ron? If anyone wants, besides contacting us, to write their email in the chat, we could just gather it and get in touch with you to schedule a demo, whether it's virtual, whether it's in the US or in other places where we're installed. We'd be happy to facilitate that.
Great. All right, you mentioned 3D scans of the vehicle. Do you have any examples of how this scan looks at the application, or the preview is available, or it's used only, or is the preview available, or is it used only to create fingerprints?
The 3D scanning is used mainly so we'll have more information about the vehicle, not only for the fingerprint, but also for detecting the anomalies in the undercarriage. It helps us to be able to recognize and to really understand how the components looks like. But also we use it in order to be able to show the anomalies we detect from different angles, so the operator eventually can understand what he sees, not only marking that there's something there, but actually to give the 3D information, how it looks from different angles, so the guard will be able to understand exactly what he sees without taking any risk, and to get a better decision. If there's other needs to use the 3D models, then definitely it's something that we can share. So just feel free to contact us, and we'll show exactly those models and what can be achieved using those models.
All right. Well, you did just mention angles, so I'll get to this question now. In which angles do you place the cameras?
So we have 5 cameras. It's a bit hard to explain in which angles, but it gives us the ability to really we have wide angles and short angles that gives us the ability to really see all the different places in the undercarriage that someone can try and use to conceal some objects. We do have enough overlap between the cameras to use it for the stereo vision to create the 3D models eventually.
All right. What kind of throughput can the system handle?
So it takes for the system a few seconds to generate the result, as we see. Every 3 to 5 seconds, we're able to scan a vehicle.
So what's important to say is that we actually made this throughput available because you can't have long traffic lines at the entrance to border crossings or an airport facility or secure perimeter. So it's a drive-through system. But what we're seeing now is that we use the same device that we call Helios in the automotive world with dealerships all across the US. And they can put the same device and also at the same throughput of a lot of vehicles in an hour, let's put it this way, can find things like oil leak. So in that sense, we have it available in Homeland Security, but the same throughput is also something we can look for mechanical damage with the undercarriage scanner in the automotive world as well.
It's kind of funny that you mentioned that, Yaron. Actually, a question came in right before you started speaking. Can you analyze if a bolt was tightened or not, and is the system able to detect oil/water leaks? So I guess you've already addressed that.
Yes.
Let's see, somebody asked, can you give us an idea of cost?
So it varies between the Homeland Security and the automotive world. We can say that our price is, on one hand, competitive, but we are by far the leaders in the market in terms of Homeland Security, in terms of being able to detect on the first pass, being able to provide this unique fingerprint ID. So you pay for quality, and it's tailored by the amount of systems, it's tailored by the amount of lanes, and obviously it's in the tens of thousands of dollars per project. Starting. In the automotive world, since we have 3 devices and different uses and use cases, I mentioned fleets, I mentioned dealerships, secondhand auctions, car marketplaces, rentals, MOT facilities, dealerships, tire shops, repair shops. We like to call it as an inspection as a service model. So it's usually a subscription that is tailored on the volume and the use cases that are needed by the client. So again, in Homeland Security, it's a fixed cost that we give a quote. You're welcome to leave your email in the comments or get in touch, and we can give you a quote according to your needs. And in the automotive world, it depends again on the volumes and depends on the use cases, and it's usually a subscription, a service that we provide.
All right, great. One little side note on my end, it looks like we have a bot that's been spamming the chat box. So apologies for that little glitch there. We'll try to fix that next time. Those are all the questions that we had. That's actually an amazing amount of questions. Clearly a lot of interest in this technology. Any parting words from you?
Yeah, I mean, first of all, I'll let Amir conclude from his end, but we are very happy to, on one hand, expose this patent and how, really reveal how we actually look at vehicle inspection, how we do things differently, how we combine artificial intelligence and deep learning to look at something that was very manual and an industry that maybe didn't use it before. And I think this patent and this example of looking at a vehicle, looking at the undercarriage, analyzing different parameters and letting us fingerprint it, letting us look at it in a unique identifier is representing to what we do here at UVeye. Because as I mentioned, we what stands behind the strength of this company is the software and it's the algorithm. We have 3 systems, a lot of different use cases in Homeland Security and Automotive, and we just know to look at a vehicle and tell you anything that's different, wrong, shouldn't be there, whether it's a mechanical issue, whether it's a security threat, whether it's a change, whether it's a modification. And again, you can look at our website and get in touch with us at info@uveye.com, or just go to our main website and get in touch. We'll be happy to schedule a demonstration and speak about your specific needs and tailor you guys an offer. And we're in big scale mode, especially in the United States now. So we have demo sites available. We have a team ready. And the mass manufacturing. So really happy to tell you more, and you're welcome to get in touch.
I couldn't say it any better. So really appreciate everyone's time. We're excited to show new technology, and we have a lot more to show. So really appreciate everyone's time. And if you have any questions or you would like to get more information, feel free to contact us.
All right, thanks, guys. Yeah, I'll just say personally, having been in a military police unit and having done vehicle searches and used the mirror underneath the vehicle, and really impressed by this technology. It's pretty cool. So thank you guys very much. Again, just to remind everybody, the website is uveye.com, uveye.com. And that concludes our presentation for today. Thank you all for joining us. Thank you, Yaron. Thank you, Amir. Once again, great presentation. And hope everybody has a great day. And Yaron, since you're the host, if you could just click the end button below the video box, we can say our goodbyes.
Thank you very much. Bye-bye. Have a great day.
Bye-bye.